we will continue the presentation of CSEC Multiple Choice Practice Paper 4, and we will be presenting Part C. Part C is another 15 problems, and will begin at problem number 31, and it will end at problem number 45. The first problem. In this first problem, we have a rectangle A, B, C, D. So we have rectangle A, B, C, D. Also, we have each side of the rectangle being bisected. And the point of bisection here is P, here is Q, R, and we have S. Of course, we have lines drawn, AC, BD, we have PR, and we have SQ. We are required to tell which pair of lines represents a pair of axes of symmetry. An axis of symmetry of a figure is a line that divides it into halves that are mirror images of each other. Therefore, if we crease a model of it along the proposed axis of symmetry and fold it, each section will fit exactly on the other. Therefore, if this is an axis of symmetry, we crease it here, then we fold it, then each part will fit exactly on the other. And of course, we know that about the axis of symmetry, each half is a mirror image of the other. Let us consider that we crease a paper model of the rectangle along AC and take note of what will happen. So we will take one half right there. So we crease it along AC, right? And this is the first half that we are considering. If we fold this figure with this line as the center, then this one will fit exactly on the other if AC is an axis of symmetry. But let us see what will happen. Let us take a look at what the result will be if we fold the paper along AC. There we have it. When we fold it, what do we know? It does not fit exactly on the other half of the rectangle. Therefore, AC is not an axis of symmetry. It does not fit exactly onto the other half of the model. AC is not an axis of symmetry. Option A is not correct. PR and SQ are axes of symmetry. Consider that the model is creased along PR and take one half of the model. So we are considering one half of the model if we fold it at PR. What will happen if we fold it over? It will fit exactly on the other side. If it is folded onto the other, it will fit perfectly. Therefore, PR is an axis of symmetry. But we are saying that PR is an axis of symmetry right here. We are also saying that SQ is an axis of symmetry. It may also be shown by similar means that SQ is also an axis of symmetry, making option B the correct one. The CSEC examiners expect us to have the spatial skills that are required to identify axes of symmetry on inspection. Therefore, they do not imagine in an examination that students will be fiddling a bit with the model that we have there. They expect us to be able to just look at it and be able to identify the axes of symmetry. PT is parallel to QS and QR is equal to RS. What is the ratio of the area of the triangle TQS to the area of the triangle PQR. We have two triangles. We have TQS, TQS, and we have PQR. We have useful information there, right in the statement of the problem. Let's make use of it. The first bit of information, that PT is parallel to QS, is given in order that we may see that the triangles are of equal height. That is very, very important. The triangles are of equal height. What information is given to us? That PT is parallel to QS. So we are sure that the heights of the triangles are equal, like that. So we have the height of the first triangle, that, and we see that it is equal to the height of the second triangle. The other bit of information, namely that QR is equal to RS, is given for us to see that the base of triangle TQS is twice the base of triangle PQR. So we are told that QR is equal to RS. Therefore, from Q to S is twice the distance from Q to R, and also twice the distance from R to S. We are sure that QS is twice QR. Therefore, the triangle TQS has a base that is twice that of PQR. The area of a triangle is dependent on two things: its base and its height. So we have area of TQS, area of PQR. Do not forget that the base of TQS is twice the base of PQR. So we have 2B for the base of TQS, and we have B for the base of PQR. The base of TQS is twice that of the base of PQR. We may represent the one that is twice as 2B and the other one as B. The triangles are of the same height. Just by considering the products inside of the brackets, we realize that the area of TQS is twice the area of PQR. The ratio is therefore 2 to 1. And the correct answer is option B. So notice that we have this is half, this is half. This is H, this is H. The only thing that makes a difference is the base. Since the base is twice of the other, then we are sure that the area is twice the area of the other. That's all there is to it. Of course, we could have determined that answer without going through this process, but this process is a matter of demonstrating to you how we could mathematically arrive at the answer, because in an examination it is expected that candidates who are aware of what to do will check the diagram and realize that the two of them are of the same height and the base of one is twice the other. Therefore, the area of one will be twice the other. The ratio is 2 to 1, so that could have been determined in seconds. We have a somewhat sophisticated figure right here, and we need to determine the value of x in centimeters. So we have, this is a right angled triangle, and also this is another right angled triangle. No other angle is given, therefore we are sure that all of our work will be by Pythagoras Theorem. Our ultimate aim is to find the length of the side x, the hypotenuse of the triangle ABC. That is the triangle that we are focusing on. There is no way that we can find any other angle or side of any triangle with only two knowns. And when we say two knowns, we mean an angle or a side or both. And in this particular case, we are assuming that the right angle is a known angle. Of course, it is known. Its size is 90 degrees. So here we have x, and we have 5 centimeters, and we have 90 degrees right here. There's no way that we can solve any triangle with only two knowns. That is, we have either two sides alone or we have two angles alone. We need a third value. In order to find the side x, we need to know at least another side or angle of a triangle. It is quite possible to determine the length of the side AC. So in order to determine the value of x, we need another dimension or another property or a known property of this triangle in order that we can find x. We need to have another side or we need an angle. The easiest one to determine is the side AC, because AC is the hypotenuse of the other right angle triangle of which the other two sides are known. Triangle ABC is the most popular of right angle triangles. Its sides are in the ratio 3 to 4 to 5. The sides are 6, 8, and x. The number that will complete the ratio is 10. The side AC is therefore equal to 10 centimeters, and we mark AC with 10 centimeters. We are saying that the most popular right angle triangle is the one in which all of the sides are in the ratio 3 to 4 to 5. And if we are considering that ratio, then we have side 6 and side 8. To complete the ratio 3, 4, 5, the other side has to be 10 centimeters, and we'll take a look at that on the next slide. So we are sure that this side is 10 centimeters, and we will need to find this side, which is the hypotenuse of the second right angle triangle. Therefore, we will apply Pythagoras Theorem again. Pythagoras Theorem may be used to find x. X is the hypotenuse of the other right angle triangle in which the two short sides are 10 centimeters and 5 centimeters. So we have Pythagoras Theorem, or a statement of Pythagoras Theorem, here in algebraic form, and we need to find the length of the hypotenuse. So we put in our 5 and our 10. 10 squared is 100 and 5 squared is 25. Put them together, we get 125. So AB is the square root of 125. So option D is correct. The square root of 125 centimeters. The correct answer is option D. Which of the following is not a quadrilateral? We have square, pentagon, parallelogram, and we have rhombus. Which one is not a quadrilateral? A quadrilateral is a four-sided figure. Any polygon with 5 sides is called a pentagon. This is all that we need to know in order to determine that option B is the correct answer. So there we have a pentagon. It has 5 sides. A square is a four-sided figure with all sides and angles equal. The size of each angle is 90 degrees, and we are talking about a square. Although everybody knows a square, I'm just mentioning some of the properties of a square and also some of the properties of a parallelogram. A parallelogram is a four-sided figure with opposite sides equal and opposite angles are also equal. A rhombus is a four-sided figure with all sides equal. As such, a square fits the description of a rhombus. However, not all rhombuses are squares. We need to determine an approximate value of the square root of 520. By considering the form of the answer in the options, let us rewrite the square root of 520 in a more compatible form. So we will write it in a form that is more compatible to the answers that we have right here, which is also a very important method in mathematics. You use the form of the answers that you need. So we will write then the square root of 520 as the square root of 5.20 multiplied by 100. In that form, 520 is reduced by 2 places of decimal. To compensate for that, we multiply the result by 100. So we reduce this by 2 places of decimal. We multiply this by 100 to compensate for the reduction by 2 places of decimal, which is of course similar to the process that we carry out when we are writing an expression in standard form. And another name for standard form is scientific notation. We may now make use of the fact that the square root of the product is equal to the product of the square root. So we have the square root of a product that is equal to the product of the square roots. So we have the product or a product of the square roots. When I mentally calculate the square root of a number that is not a square number and give an answer close to the actual value, my students always think that I'm very smart. That may be true, but you can do it too. In determining the square root of a number that is not a square number, take note of the square number that is close to it. So take note of the square number or a square number that is close to it. In this example, we need the square root of 5.2. The nearest square number to it is 4. The square root of 4 is 2. 5.2 being a bit larger than 4, we expect its square root to be a bit larger than 2. So we need the square root of 5.2. The closest square number to 5.2 is 4, and the square root of 4 is 2. 5.2 is a bit greater than 4, so we expect its square root to be a bit greater than 2. So 2.3 is what we expect, according to the information that we have in the options there. The square root of 100 is 10. We therefore multiply 2.3 by 10. Right. The correct answer is option A. Mr. Jones paid a fixed charge of $12.50 plus 55 cents for each kilowatt hour of electricity used. How much did he pay for using 75 kilowatt hour of electricity? This problem is pretty much straightforward. All we need to do is add the charge of using 75 kilowatt hour at 55 cents per kilowatt hour to the fixed charge of $12.50. So we need to add the charge of the kilowatt hour to $12.50. In a multiple choice exam, we may not use a calculator, so we will have to carry out the multiplication rough or in our minds. In order to save time, we will make 55 the multiplier since the digits are the same. This will shorten the time required. So let us see how that will shorten the time required. We have 75 multiplied by 55. Like in primary school, we used to enjoy these multiplications. 5 multiplied by 5 is 25. We will write down 5 and carry 2 to the more significant place. So 5 goes there, 2 goes there. And 5 multiplied by 7 is 35. Then we add the 2 to the 35 and we get 37. Right. The other digit by which we will multiply will be the same. So we will multiply by 5 again. Therefore, we do not need to go through the process. We include the placeholder in 0. And after including the placeholder in 0, the rest of the product will be the same. Right, so we are saving time by using 55 as the multiplier because we multiply by 5 already, we get 375. Now we multiply by 5 again. We know that the answer is 375 again. So we put the placeholder in 0, then we put the 375, saving time in our multiplication. If we did 55 multiplied by 75, we would probably have to do multiplication twice. But since we use 5, then we are using 5 again, then we just write down the answers. We need to add the results. And what do we get? 4,125. Do not forget that the 55 that we multiplied by was actually 55 cents, which is 0.55 of a dollar. The answer needs to have 2 places of decimal. So we will have 2 places of decimal. There we have our 2 places of decimal. There we have the answer with our 2 places of decimal. And no doubt we have $41.25. There we have it, $41.25. And option B is correct. Or so we think. I almost got caught with this same problem because I did not remember to add the fixed charge of $12.50. So do not forget to add $12.50. So when we add $12.50, we get $53.75. Alright, so if you did not remember to add the $12.50, we have the option there for you. The option is there for those who did not remember to add the fixed charge, and the fixed charge is $12.50. But now that we have added the $12.50, we are sure that the correct answer is option C, $53.75. The option is C instead of B. During a sale, a discount of 15% was given off the marked price of a chair. If the marked price was $115, then the sale price was $100. Well, it would appear to be $100 just by glancing at it. Although it is not impossible, reducing $115 by 15% is a little awkward without a calculator. Surely, that is what is required with the problem asking for a discounted price when the marked price is given. We are stating already that the correct answer is option A, but let's see if we can verify that. After reading the problem, it did not take me an additional 2 seconds to determine that option A is correct. And you should be able to do it too. This is one problem that did not require that you work it out. Just use your common sense and arrive at the answer. 15% of 100 is 15. If you can see this, then you are on your way. If not, you will have to go through a longer process. 115 is greater than 100. Therefore, 15% of 115 must be greater than 15. So, 15% of 100 is 15. 115 is greater than 100. Therefore, 15% of 115 must be greater than 15% of 100, which is 15. Therefore, if we are reducing 115 by 15%, we will be taking away a larger number than 15 from 115. And if we take a larger number than 15 from 115, the result will be less than 100. So from 115, you are subtracting a number that is greater than 15. The result must be less than 100. The only number in the options that is less than 100 is 97.75, and this belongs to option A. So although it took a year and a half to explain it, the evaluation can be made mentally in a matter of seconds, and we should be able to determine in those seconds that option A is actually correct. What is the exact value of 2 divided by 0.01? From our work in primary school, we know that 0.01 is equal to 1 over 100. We may rewrite the arithmetic operation. Instead of writing divide by 0.01, we will write divide by 1 over 100. So 2 is being divided by 1 over 100. Dividing by a fraction is the same as multiplying by its multiplicative inverse. So we will multiply by the reciprocal of the fraction. And what do we get? 2 multiplied by 100, and that is equal to 200. The correct answer is option C. The width of a block of wood with rectangular cross-section is x centimeters. Its height is 2/3 its width, and its length is 4 times its height. What is its volume in centimeters cubed? We may begin with a representation of the rectangular block. There we have our rectangular block. The width is x centimeters. No problem. The height is 2/3 of the width. This means 2/3 of x. No problem with that. Its length is 4 times its height. We know 4 times its height. Some students misinterpreting the problem or not keeping the information correctly in their minds will write the length is 4 times the width. It's actually 4 times the height. So we will multiply its height by 4. Volume is equal to length multiplied by width multiplied by height. To find the volume, we will multiply all of those. And 4 will act like a fraction whose denominator is 1. So we will be multiplying x, 2/3 of x, and 4 times 2/3 of x. This 4 will act as a fraction with the denominator of 1. So there we have that length, then the height, then the width. So we multiply the length by the height by the width. Right. Multiply the numerators. So we are going to be multiplying the numerators. So we'll be multiplying the numerators. And we have the numerators 4 by 2 by 2. So we have 4 multiplied by 2 is 16. We will proceed to multiply the denominators. We have 1 by 3 by 3. Anything multiplied by 1 is that same thing, so we may say 3 multiplied by 3 is 9. Then we have the x's. X multiplied by x multiplied by x, and that will be x cubed. So we will have 16 over 9 and x cubed, and that will be option B. So the correct answer is option B. A car was bought for $10,000 in January 1997. If the car depreciates by 10% every year, what was its worth in January 2000? If one rightly understands depreciation to be somewhat the opposite of compound interest, solving the problem may not be difficult but tedious, especially that we may not use a calculator. However, if in addition to that, we understand the effect of compound interest and depreciation on trailing zeros, then we will not have any problem identifying option B as the correct one. So option B is correct, and we just identify that in a matter of seconds, because we understand the effect of compound interest and depreciation on trailing zeros. The value will go down by 10%. This will take it to 90%. 90% is equal to 90 divided by 100, which is equal to 0.9. Multiplying by a number that has a decimal place like 0.9 that we have right there has a tendency to increase the number of decimal places of the multiplicand. In this particular case, the multiplicand is cushioned by trailing zeros. The trailing zeros will have to be removed before the decimal place will begin to appear. I did not imagine that the examiners expected us to take 3 steps of a depreciation problem under examination conditions on a multiple choice paper. As a matter of fact, I cannot remember seeing it, that is, a problem that required 3 steps of a depreciation problem on an essay paper. Sometimes the most difficult problems may not require that we solve them at all. This is just one of the advantages of a multiple choice examination. All of the answers are there. So because all of the answers are here, all we need to do is to be able to identify the correct one. If we can do that in a matter of seconds, which we should be able to do in this particular case, then our problem is solved. Do not forget that we are depreciating by a particular percentage, and this will cause the trailing zeros to be somewhat distorted. So we will have a progressive removal of the trailing zeros in the answer. Or if we did not have trailing zeros, then we will begin to have an increase in the number of decimal places, and it is because of that effect why we are able to identify option B as the correct answer in a matter of seconds. The simple interest on $15,000 for 3 months at 10% per annum will be this seems to be a pretty much straightforward simple interest problem. This is the type that candidates dive into and end up getting wrong because they neglect the fact that although the rate is given per annum, the time is given in months, not years, months. Interest is equal to principal times rate times time. I'm not including the part that we divide by 100 there because the rate is a percentage. So dividing by 100 is a part of the rate. To convert the 3 months to years, we divide by 12. This will give a quarter of a year. So instead of putting 3 over 12 for the time, we know that 3 months is a quarter of a year, so we just put in quarter. So we will do the substitution now. The formula contained no divide by 100 because the rate is a percentage. So 10% is 10 divided by 100. When we include the rate, the 100 is automatically included. The fraction may be reduced by a common factor of 100, and that may be achieved by striking off 2 zeros from both denominator and numerator. As easy as that. We may reduce by a common factor of 2, then by a common factor of 2, in which we say 4 divided by 2 is 2, and 10 divided by 2 is 5. Then we divide by 2 again. We say 2 into 2 is 1. 2 into 150 is 75. Do you remember from the previous problem, that is problem 36, that 75 multiplied by 5 is 375? We could just throw that in based on memory. But if you did not remember, we still could work it out. $375. The correct answer is option A. We need to determine which of those options will represent the graph of the inequality that we have right there. The only difficulty in arriving at the answer lies in reading the diagram. We must be able to read that diagram that has all the numbers and, of course, this device that we have right here. So the difficulty, or the greatest difficulty, lies in reading the diagram. The bold line indicates the region involved. It goes from -2 to 2. The endpoints indicators are opened, not shaded. This indicates that the endpoints are not to be included. So in the inequality, these endpoints are not to be included because we did not have the shaded one right here or the shaded one right here. We have them opened. So we are sure that the endpoints are not to be included. We therefore need the inequality among the options that indicates a range that is between -2 and 2. And of course in which both -2 and 2 are excluded. So we will go from -2 to 2, but the endpoints are not to be included. They are excluded. We will also do well to consider the less than or equal to sign and also the greater than or equal to sign, and that they imply that the endpoints are included. So in the event that we have any representation that has these signs, this means that the point involved is included. But according to what we have here, they should not be included. Therefore, any option that contains any of the less than or equal to or greater than or equal to sign are automatically excluded, because the open dots indicate that the endpoints are not included. So this sign, this, and this, they all mean less than or equal to. Less than or equal to. That means the endpoints are to be included. But according to what we have here, the endpoints are not to be included. Therefore, any option that has those signs will be excluded, and the correct answer is option A. The correct answer is option A. What is the perimeter of the shape? We need to determine the perimeter of this shape. All around. Good. Perimeter, the measurement or the distance around. We need to find the perimeter of the shape, but some sides are missing. Let us first find them. So let us first find the missing sides before we are able to determine the perimeter of the shape. Notice what we have there. This side 8 centimeters, and it is comprised of two sides. One is 6 centimeters. What is the other one? 8 minus 6 is equal to 2 centimeters. Therefore, that side is 2 centimeters. We need to find the other side, of which we know that this is 6 centimeters. We do not know this, but this is 4 centimeters. Therefore, if this is 6 and this is 4, then we know that that is also 2 centimeters. 6 minus 4 is equal to 2 centimeters. Then we may proceed to find the perimeter. We are going to take a look at each side. The perimeter is the entire distance around the figure. This is equal to the sum of the sides. Add the sides as we go around the figure. That makes a lot of sense. The first one is that one, 8 centimeters. The other one is 6 centimeters. The other, 2 centimeters. Then 4 centimeters. Then 6 centimeters. Then finally, another 2 centimeters. This can be added quite quickly. We have 8 plus 2 is 10, 6 plus 4 is 10, so that is 20, and 6 plus 2 is 8. So we have 28. Perimeter is equal to 28 centimeters. The correct answer is option C. 28 centimeters. The set that we have there that says the set of x such that 6 is less than or equal to x is less than or equal to 10. And we know that we are talking about integers according to the statement of the problem. And we need to know which set among the options is representative of the one that we have in that statement of the problem. The expression that defines this set may be read: 6 is less than or equal to x, while x is less than or equal to 10. This means that the value of x will range from 6 to 10 and will be inclusive of 6 and 10. Must be inclusive of 6 and 10 because we have the or equal to here, or equal to. So we know 6 is less than or equal to, not less than or equal to, and we have x is less than or equal to 10. So because of this or equal to, we are sure that 6 and 10 are to be included. The set that fits this description is that of option B, in which 6 and 10 are also included. This is the situation that we have in problem number 45. The length of AB is 32 centimeters. OB is 20 centimeters. Therefore, since OB is 20 centimeters and it is the radius of the circle, OA is also equal to 20 centimeters because it is also the radius of the circle. Also, we have OM, which is the perpendicular bisector of AB. That means the line that goes from O to M is perpendicular to AB, and it divides AB into 2 equal parts. At a glance, the alert candidate will be able to determine that the answer is 12 centimeters. That is, we need to find the length of OM. Finding the length of OM, the alert candidate will be able to see that the answer is actually 12 centimeters. How so? The marking of the two right angles demonstrates that OM is the perpendicular bisector of AB. So we have here and there. So we are sure that OM is the perpendicular bisector of AB. It has to be because OA and OB are radii of the circle and are therefore equal. So we are sure that OB is equal to OA 20 centimeters each. Therefore, if we have these marked angles here to be right angles, since this is equal to this, we are sure that this line will divide AB into equal parts. AM and BM are both 16 centimeters. So let us include that. Both of them are 16 centimeters in length. We therefore have two right angled triangles in which the hypotenuses are equal to 20 centimeters and the known short sides are equal to 16 centimeters. So we have two right angled triangle, hypotenuse 20 centimeters over here, also because of the radius 20 centimeters. This is 16, this is 16. We need to find OM. Do not forget, the sides of the right angled triangle are therefore in the ratio 3 to 4 to 5. Do not forget, 3, 4, 5 is the most popular right angled triangle. And if we can, in our minds, see that the triangle that we have is 3, 4, 5, then it is easy to determine the missing side. So the 3, 4, 5 is the most popular right angled triangle. The other side must therefore be 12 centimeters, and we will see how that may be determined. On the next slides, we will take a look at how we may arrive at the answer under the microscope and use the traditional way to solve the problem. OM is one missing short side of the right angled triangle. That is what OM is, a missing short side, because we have the hypotenuse and the other short side. Look at the ratio of the given sides. We know what the ratio is. 20 to 16. Those are the two sides that are given. The numbers may be reduced by a common factor of 4. 16 divided by 4 is 4, and 20 divided by 4 is 5. So we have sides 5 and 4. But it is not legitimate unless the longest side, which is side 5, is actually the hypotenuse. There we see 4 and 5. According to the information that we have, side 20 that reduced to 5 is the hypotenuse. This is as required. The longest side, the hypotenuse, needs to be side 5 if we may safely conclude that the missing one is actually side 3. So there we have it. Side 3 is the one that is missing. We have 5, 4, 3, or 3, 4, 5. 5, 20, 4, 16. We know, because we have divided by 4, that the factor is actually 4. So 4, 3 is 12. The multiplication factor is 4. 3 multiplied by 4 is equal to 12. Right, so the factor that we use here, from 5 to go to 20 is 4. From 4 to go to 16 is 4. Therefore, from 3 to go to 12 is 4. One may say that the process is lengthy. Do not forget that the process is to be carried out mentally. The right-angled triangle is identified to be 3, 4, 5. The given sides are a part of the ratio. We will see that the other side is 12 quite quickly, and that we have already done. If candidates are sharp and adept numerically, then just by inspection the students will say, this is 20, all of this is 32, 16 on either side. This looks like right angled triangle, 3, 4, 5. This is side 5. How do we get 20 then? 20 divided by 4 is 5. Therefore, if this is side 3, we just multiply by 4 and we get 3 4 is 12. And that's all there is to it. Pythagoras Theorem may also be used in solving the problem. Let us apply the form that is relevant to the situation in which one of the short side is missing. So we are applying Pythagoras Theorem, and we are applying it in the form that we have one of the short side is missing. So we will substitute the hypotenuse and the other short side, 20 and 16. So hypotenuse is 20, the other short side is 16. And when we square, we get 400 and 256. So OM is equal to the square root of 144, which is what we get when we subtract 256 from 400. The square root of 144 is 12. So OM is actually 12 centimeters. The theorem has confirmed that we were right in the first place. Some students may just look at this and say, well, why not use Pythagoras Theorem? It has just a few short steps. The thing is, it is the explanation of the mental process that was previously discussed that takes a long time. The mental process does not take a long time if you identify that the triangle is 3, 4, 5. Then it is automatic what the other side will be, and it will take just a matter of a few seconds. The correct answer is option C, that we have confirmed.